everyone. Today, Kava Robotics will be presenting their NASA Mars rover final report for Section 1 of FAMU FSU First Year Engineering Lab, Summer 2022. Overview. First, the team will take you into introductions so you can get to know them better. Then you will go through background of the rover. Then phase 1, which is our summary. Phase 2 is manufacturing activity, test results, redesign, and then finally, you will see the conclusion. Kava Robotics team consists of manufacturing lead 2, Keenan Bailey, project manager, Allison Beltrani, test and software engineer, Victoria Hernandez, and manufacturing lead 1, Amina Nabolsi.
Background request for proposals. This is the request for proposals provided by NASA that consists of our tasks and expectations throughout our Mars rover project. The customer requirements document consisted of including the NASA Mars rover shall gather scientific data on the surface of Mars. It's expected that the NASA Mars rover must travel on the surface of Mars by navigating terrain, avoiding obstacles, and following commands. Also, the NASA Mars rover must achieve line tracking, obstacle avoidance, and Bluetooth control. The preliminary contractor requirements include the Mars rover shall have sensors to detect obstacles. The Mars rover shall have sensors to detect line tracking. The Mars rover shall have rugged, durable wheels and tires. The Mars rover shall have electronic control modules. The Mars rover shall be able to receive controls through an infrared receiver. The Mars rover shall be controlled by a Bluetooth module. The Mars rover shall be driving at optimal performance on account of symmetrically aligned tires. And also the Mars rover shall be able to drive according to the line tracking sensor. Some of the changes and deviations from assembly instructions that the team faced are first, improperly attaching the UNO R3 core band and infrared receiver. Because of this, the team was unable to connect the L298N cord to the core board. Because of this, they had to remove it and reattach it properly according to the manual instructions. Also, the team had improperly attached the line tracking module. It was backwards, and because of this, the Mars rover was not following a straight direction whenever it would drive. To fix this issue, the team had removed it and reattached it properly. Also, the team had faced loosely attached wheels throughout their assembly, and because of this, as it drove along the line tracking, 2 of the wheels were driving at a faster pace than the other 2.
The team faced some challenges throughout the project. Some challenges the team faced was connecting the wires to the core board. The team put the upper and lower acrylic together incorrectly. Because of this, they had to take the rover apart and start over again. Another challenge the team faced was that they put the ultrasonic sensor the wrong way in the microserver. When testing the rover, the team noticed the wheels were spinning opposite ways on opposite sides. Because of this, it did not drive smoothly. Neither did the team or Professor Burns could figure out why. Some changes that would have been helpful building the rover would be if the directions were to show a more detailed and realistic view. Some challenges that can be improved with changes to the assembly are if the team assembled the rover in the correct order, like in the instructions, it would have kept them more organized and resulted in less mistakes. These are the signatures from Dr. Burns on our inspection.
The team was able to successfully complete line tracking demonstration on easy, medium, hard, and the team successfully demonstrated obstacle avoidance. There was an issue with Bluetooth control, but is able to be excused under special circumstances. Here are the 3 demonstrations of the rover's success in the line tracking task. The team was successful in the download and upload of software, and it ultimately succeeded on all 3 tracks. There was a small issue dealing with hardware that could not be solved, where the wheels were turning in different directions, but it did not stop the rover from line tracking. It was also inconsistent in the beginning, but eventually started working. This may have been due to the sensor picking up on the wrong part of the track. Here's the video of obstacle avoidance. Okay, as you can see, the team was ultimately successful in the obstacle avoidance task. However, we did encounter a problem where the sensors would not move. It completed its function, but the robot had never lit up or moved around. Again, this was inconsistent. The team successfully attached the Bluetooth to the rover, causing it to light up. However, the team was unsuccessful in completing the task due to an app update that was not compatible. If the app was working, the team would have been able to upload the program Bluetooth car to the UNO control board, and we would have been able to set up parameters. We would have been able to set up forward, backwards, left, right, stop, and control it from our phone. Hitting the task due to an app update that was not compatible. If the app was working, the team would have been able to upload the program Bluetooth car to the UNO control board, and we would have been able to set up parameters. We would have been able to set up forward, backwards, left, right, stop, and control it from our phone. Line tracking was uploaded so that the rover could follow the lines. Obstacle avoidance was uploaded so it could avoid anything in its path. Also, a file was uploaded to debug that file. Bluetooth car was uploaded so we could control the rover from our phones, and Bluetooth Blink was uploaded to aid that. The only software problem that the team encountered was obstacle avoidance, as it had to be debugged, and also a problem with the compatibility of the app with Bluetooth.
Conclusions, comments, and takeaways. What did we accomplish? The team were able to successfully build a fully functioning rover by following assembly instructions provided in an hour. The team made few mistakes in the assembly of the car, which could have been prevented if the project manager and the software and test engineer would have assisted in the assembly of the rover in order to prevent any future backtracking. The team's rover resulted in successful line tracking of the easy, medium, and hard courses and successfully avoided obstacles. The team's only challenge with the rework/redesign efforts was the software and test engineers had to debug the Bluetooth. Also, because of the app update, the team was unable in connecting the Bluetooth to the rover. Thank you so much for your time. Kava Robotics hopes you enjoyed their NASA Mars rover final report.